水5号老师，
嗯， Yeah, do my PPT?
Yes, 老师。
Yeah.
Yes, 老师。Yes, 老师。
We will begin a class. This class we will study that the chapter 11, the last chapter of the physiology. The chapter 11 that the endocrine system, 内分泌系统. We have studied that the body regulation include that yeah, do you remember? We have studied that the chapter 1, we have studied that our body's regulation include that three kind of regulation. Who can tell me? Who can tell me our body's regulation, three kind of regulation? Who can tell me?
Nana 老师。
Yeah, can you tell me?
Neuroregulation, hormonal regulation, and then auto-regulation.
Very good, thank you. 谢谢娜娜。And we have studied that the new regulation and the hormone regulation and also auto regulation. And they are major and important and almost the major regulation is the new regulation. New regulation we have studied that the many factors like that the heart, the cardiac vessels, and also the kidney and the gastrointestinal. And we have studied that the chapter term, the nervous system. We have known that the neural regulation all of the body, and also most very important the regulation and major regulation, but also that hormone regulation. Hormone regulation also we have studied in some like that the cardiovascular and some many chapters, but there I have know that there major the hormone regulation based on that the endocrine system. The endocrine system there. So here that this chapter we will study that the endocrine system. We will study this endocrine system immediately after the first. The hormone regulation also based on the hormones, and they are section 2 the hypothalamus, pituitary, and also pineal endocrine, and also section 3 the thyroid endocrine, and also that the section 4. Section 4 because in the clinic you may in the surgery and also maybe surgery. There may be face some of the cut the surgeries, and also they are maybe pay attention to the around the cells, the organs. So here that is section 4. We will study that, but I hope you know that. Okay. And also that the section 3, Iceland in endocrine, and there is also that the section 6 endocrine and the endocrine glands. There and first that we will study that the section 1 endocrine and hormones, and also that is 内分泌与激素. We have known that there the endocrine is also that his functions can act based on the hormones, and they are in section 1. Here that I hope you master the knowledge objections, and also master the general characteristic of the hormone action, and also that concept of the endocrine hormone and the permissive action, and also the physical action of the growth hormone and its major regulation of the secret. This is also that the section 2. And familiar with the mechanism of action of the hormones. The mechanism of the action of the hormones, I hope you know that there is very important the theory that the second messenger theory, and also some that the gene expression theory. This is two theory about the mechanism of the action of the hormones. I hope you know that. Okay. and and also that action, these actions know that okay, and there, and they have here that the and also the functions of the neural physics, you know that okay, yeah, and also that also that in the emotional objections, also that I hope you that the endocrine also and the hormones also is keep the balance of the body, also that emotions and also behaviors, so that if the endocrine dysfunctions or the hormones imbalance, also maybe lead to the people's many disease, and also some of the, and also even like that the emotion disease, and also the psychological disease, maybe according to the endocrine and hormones. Yeah, and there first section one, there we will study the endocrine. The endocrine we can see here that there first that the what is the endocrine? Endocrine is a method. Also, we just talk about that is also the regulation method or past method way. Then what is the endocrine? Endocrine Chinese name is 内分泌. Endocrine it refers to a secretion method. Secretion method in which that endocrine cell we can see endocrine, this cell endocrine. Endocrine cell secrete the hormones directly into body fluid, and use blood and other body fluid as a medium to have a regulatory effect on the target cells or target organs. Target organs or target organs is also that it follows the target cells and also the target gland and so on. We can see this cell is all we call the target cell, and also this cell is the endocrine cell. Endocrine cell, he can secrete the hormones. There are the hormones directly into the body fluid, and also the body fluid. Then like the blood or other body fluid and tissue fluid, and this also that the other body fluid, and as a medium, and then have to regulatory the effect. It means that he regulates the target cells, and there he act on binding the target cells, They are binding also that like the receptor, and also then this is a target. The endocrine cells release the hormones. Yeah, understand here?
Yes, Laoshi.
Yeah. So that is there is a secret method. This method that also that the actual is different from the actual cream. And here that we just about that the endocrine cells or endocrine organ gland or organs, he can secrete the hormones. Then what is the hormones? Hormones Chinese name is 激素. I think about that in your life you have also know that hormone. Yeah.
Yes, Laoshi.
Yeah, you have heard the hormone. Yeah. We have known that like that the young girl also follow the hormones. Then means also that the hormones is also the cellular hormone. And then hormones, I hope you study the physiology. You should know that what is the hormone. Hormone is means that this materials is be synthesized and secreted by the endocrine cells. Like that, we can see the point is the hormone. And also this endocrine cells of the endocrine gland or organs tissues. Is the endocrine gland or all the organ tissues. Also that like the gastrointestinal. This also can in the gastrointestinal the cells also maybe have some of the cells also have the ability to secrete the hormones. And also there this material, this substance used in body fluid as a medium. and also that they can high efficiency biologically activity substance. Then the substance that can deliver ubiquitously information between the cells. Between cells, it means that this one cell, two cell, or another kind of cell, and it means that this cell function can be regulated by the another cells, the another kind of cells. These cells also then regulate this second cells. This cell there also there by pathway that the substance is the hormone. Is also that these cells, these endocrine cells release the substance. This substance can be transported by the body fluid, like that blood or tooth fluid and so on. Body fluid, and then around the target cell, around the target cell, and also then he binding target cell, and also then have a highly efficiency biological activity, and the target cells functions. So that we also know that this is the substance is also that have a higher efficiency biologically activity. Higher efficiency biologically activity, it means that his or lower constitution, but that his higher efficiency functions. Higher efficiency functions, and there is also that we can see here that this cells information also then around the another cells infection. So that I hope you understand what is the hormone. Hormone is that first that you should know that he be secrete the endocrine cells, be secret, and also they are synthesized and secret by the endocrine cells, and also that transport by the body fluid, and also that this substance is also that higher efficiency biologically activities. There is a substance, and also there here can regulate the another cells functions. Then we call the hormone. Yeah. Understand?
Yes, understand.
Yeah. So I hope you know that the hormone not only can be synthesized secret by the endocrine gland, but also in some organ tissues. In some organ tissues also they have the endocrine cells, and then have the synthesize and secret the hormones. Yeah. Here that I hope you understand that what is the endocrine and what is the hormones, and also that the endocrine there is also that the hormone, we can see here the hormone deliver the hormone delivery information, the way of the hormone delivery information. Normally that is 5 ways. One also we call it endocrine. It's also that tenicrine is also that it means that transport by the blood to the distant target tissues. It means that these hormones be secreted by the endocrine cells, and then be transported by the blood. We have know the blood flow and all the target cells and have the functions. We call that is the tenicrine. Also that we call endocrine. Endocrine is also we normally saw endocrine is also that is telecrine. It means that telecrine. And another that it act on the hormones that is also that hormones act on the adjacent cells by the diffusion of the tooth fluid. It means that the endocrine cells release the hormones, and then these hormones that by the tooth fluid and also then adjacent cells, and also that this adjacent cells is around or near to the and there is also diffusion by the fluid, diffusion by the tooth fluid. There is we can see here is also we also call that this way is also pericrine. Yeah. And also the autocrine. Autocrine means that there are this endocrine cells release the hormones, and also that return to and also that act on the itself and act on the itself, and also that this also the local diffusion return to the act on itself, and even some of the neural secretion. And we just found that the endocrine cells, and also some of the tooth organs like that, the neurons, and also some of the neurons also have in the brain, and some neurons also can release the neurotransmitter, but also have released some hormones, and also that is also that we can see here that we call that the new secretion. And also the new endocrine cells, it also means that this cells is a neuron, but also have the endocrine, and also that he can release the hormones. And new endocrine cells release the hormones into the blood. And also that some also the hormones are secreted into the lemon. There we call that the endocrine. Yeah. We can see like that the telecrine normally that like the T3 and T4 is also the thyroid hormones, that is the T3 and T4 is also that by the telecrine. And also that like that gastrin and glucagon. Gastrin and also glucagon, also that he can act on the adjusted cells, is also that the pericrine. And also some of the insulin. Insulin we also that not only insulin can be transported by the blood to distant target cells, but also he can regulate itself functions. Insulin, we have know that he also that he need to the muscles. He the target organs include muscles and that, but that he can also regulate itself. Yeah. And also new secretion, and also like that the HRP also the be secret the neurons, and also that like that the pituitary portal system, and also pituitary gland. This also have the neuron secretion functions, and also that he can secrete these neurons in the peptide partial system. He can also that the hyposynaptic regulation peptide. Also that there are like that the certain gastrointestinal hormones. We have known that we have studied that chapter 6, the chapter 7. We have studied the gastrointestinal system. There are also secret the hormones there is into the lemon. Yeah. The ways of the hormone deliver information. Do you understand?
Yes, I understand.
Okay. And also that this examples, I hope you know that if ask you choose that, you should know that the like this example that the way of the hormone. Yeah. And we just talk about that there are this endocrine cells, and also the target cells, and these endocrine cells can secrete the hormones and then into the blood, and then transported by the blood and around to the distant target cells, and also act that we call that the telecrine. And also that this is also that we can see this endocrine is also this endocrine cells release the hormone, and also in the cell also regulate the cell's function. And also that we can see here this autocrine and diffusion local diffusion, and this cells this endocrine cells release the hormones, and then by the local diffusion, and also that we can see here that is also that regulate itself function. We call that the autocrine. And also that we can see here that like the in the in the peptides and also in the hypothalamus, and there also can have the endocrine cells. Endocrine cells also release the hormones. We also call this the neo secretion, and there is also and we can see here that there is also that the into the this cells also the hormones into the blood in local circulation, and also in by the tooth fluid diffusion and around the Janssen cells, and also they can regulate the Janssen cells functions. We call also that this is the this are the paracrine. And now we can see here that the by the local circulation, and also regulate the Janssen cells. They are also that is paracrine. Here also that I hope you know that they are according to the transport pathway, and also according to the distance or far or near to the cells. Also that we can classify it the many ways of the deliver pathway. Yeah, is that here?
Yes.
Okay. I hope you know that we can see like that this endocrine also that we can see here the paracrine and also the endocrine. Endocrine is also we just about that the telecrine. Telecrine is also like the we normally say the endocrine means the paracrine is also the common way of the hormones, the common way of the deliver hormones. Yeah, and then we just about the endocrine cells and endocrine. Endocrine their system. Endocrine system is that is composed of the classical endocrine gland or the endocrine gland, also the endocrine or tissue or organs is have the endocrine functions, and their functional organs and the tissues that can produce the hormones. We can see here that there are in the body also that we can many the endocrine gland like that the hypothalamus is also that the pituitary gland, and also the pineal gland, and also we can see here that this is the thyroid gland, and also the stomach and the liver, and also the major that the endocrine gland, and also that the ovities, the female and the male, the different that have the hormones. And we have known that the endocrine is that this the classical endocrine gland, and the functional organs or tissues. Functional organ and tissues also like that the intestinal, and also that the stomach also have the functional tissues, and can produce the hormones. It is the regulatory system that releases the information and integrate body functions. And there he releases the information. And there is also that integrate the body hormones, body functions. And there is the pathway immediately that the hormone that we have know that the endocrine function based on the hormone. The hormone that we can know that the endocrine gland and the endocrine cells, this endocrine and the endocrine cells, they all release the secrete the hormones. Secrete hormones that they are we call the secret hormone, the higher potency bioactivity substance. This substance also that hormones, and they are by the transport by or delivered by the blood or tissue fluid, and also their transfer, and also play a role in the body. Is based on the hormone, and the hormones that yeah. And here that I hope you know that their hormones we have the blood, especially the hormones can be transported by blood. The blood in our body all around the body, and also that the hormones can regulate the over regulation of the hormones. it means that first that the hormones that he integrate body homeostasis, then also that the regulate, and also he can regulate the metabolism. We will study that in many kinds of the hormones, he can regulate the metabolism and also regulate to the three kind of the materials, and also like that the fat and the proteins, and also the signals the metabolism. And also that he can maintain the growth and the development, like that the growth hormone. And many hormones also take part in the growth and the development. Also that maintain the productive process. Yeah. So here we know that the hormones is also have a very important in our body. Then according to the hormones, and we have know that in many different the endocrine cells have released and secrete the different hormones, and according to the hormones, especially can be the chemical properties of the hormones can be classified the hormones majorly three kind. For that kind that the amino hormones is included that epinephrine, and also the norepinephrine, and we can, and also the sorexin, we can also that we like that NE and E also we have now that is a new transmitter. Yeah.
Yes, sure.
Yeah. So that we have know that the neurotransmitter is also that we can see here that is also the hormone, and there is also that we there, and also if you're interested, you can research that the difference from the neurotransmitter, and also that the hormones. Yeah.
Yes, sure.
Can you compare that to the neurotransmitter and the hormones? Yeah. Study that the neurotransmitter also then transmitter, and also that he can be synthesized or generated by the pre-synaptic neuron. Yeah, and also that also he can be be released by the pre-synaptic memory, and also act on the post-synaptic memory. So here there also that he can be generalized, and also broken down, and also he can be reintaked by the recycled by the pre-synaptic cells and the neurons. So here that there are also that this that the materials is not the material is the neurotransmitter should be that he have the conditions. Hormones, we have know the hormones is also that he normally that is he the endocrine cells. The endocrine cells also he can be transported by the blood, and also that he has a higher effective biological activities, and also that he can act on the target cells. Yeah. So here that we can see here that the condition of the neurotransmitter is more than the hormones. Then I have known that this according to the hormones there is the amino hormones include the epinephrine, and also norepinephrine, and also sorexin. Yeah. And also peptide and the protein hormones. The peptide and protein hormones, and also like that the especially HRP. HRP is also the hypothalamic regulatory peptide. We will study that later. And also some of the peptide hormones, and also the calcicillin and gastrointestinal hormones is also the peptide and the protein hormones. This is the second. And the third that we call that the lipid hormones. Lipid hormones, we can like that this also like that the steroid hormones. Steroid hormones that is these hormones secreted by the androgen cortex and gland, and also that the calcium, and also some that and also that acetylsenators, like that thromboxane and also NACUS and prostaglandins. This also that lipid hormones. Yeah. So according receptor utilization. Receptor utilization is that the natural utilization and function cannot be destroy or use the receptor to the and also the we have know that most of the receptor is potent. Yeah, we have studied that the structure of the cell memory or experiment method. Yeah, and the hormone receptor, and also we call that this hormones and act on these receptors. There we call that. Yeah, I'm sorry. We call that this is also that this receptor and also binding G protein. And the G protein there is also that the G protein is three chains and alpha, beta and gamma chains. And normally that in the resting and alpha, beta, gamma is bonding together. And there if that the hormones binding the receptor, and also then into the G protein's structure change. And there we call that the hormone mediated by the G protein coupled receptor. We call that this receptor is coupled the G protein. And then this is theory we call that the second messenger theory. Yeah, we can see here that the first messages is that the hormones or neurotransmitter. We just talk about NE and E, and also that is not only neurotransmitter but also hormones. And then we can see here that the hormones that they are around these target cells, and then binding the receptor. We can see he binding the cell membrane specific receptor, the binding this receptor. But this receptor is coupled to the G protein. We can see G protein in the cell, and this receptor is on the cell membrane. Yeah, and this binding the cell, and also they need to that the G protein's structure change, and the G protein structure change, and then he can activate the endolytic cyclase. We call that AC. And also then he needed to the AC activity. AC activity can lead to that also based on the medicines ions and also ATP, and they need ADP become to the CMP, and also then he need to the AMP become to a CMP. Here that. It means that he based the AC actions, and they need to ATP become to the CMP, and the CMP. I hope you know that CMP is in here is the second message and the CMP can activate many kind of the proteins or the enzymes, and also then like that he can need to the he can activate the CMP dependent the pKa, and also they need to many kind of we can see here these enzymes, and also they need to this enzyme become activity, and also this activity also they need to cells of the enzymes become to the activity enzymes, and also then we can see here that need to the cells actions change. So the cell we can see here that he and also then he last then he need to the intracellular biological effects. Then we can see here that by the this hormones action based on that first that the membrane receptor. The membrane receptor is compound to the G protein, and the G protein, and then he can lead to the ATP. He can lead to the AC activity, and then AC activity, and then lead to the ATP become the CMP, and also then lead to CMP, and also then he can activate many kind of the CMP developed the PK, and also activate many kind of the enzymes, and also they need to the intracellular biological effects. So that we call that the CMP, the second messenger. Yeah, understand?
Yes, solution.
Because in the cell, many or not on a series of the enzymes can be activated by the CMP. So that we can see here that the first messenger is the hormone or the neurotransmitter. The second messenger is the CMP in this hormone mediated dependence coupled receptor. I hope you understand that. Yeah. And here that this we call this the second message. So that I hope you know that what is the second message. Then also like that we can see here that we just talk about that this is the the memory receptor, and also he bounding to also coupled by the G protein. G protein have the 3 10 and also alpha beta gamma. We can see here that, and then you have seen also that this alpha beta gamma is bonding together. But that if the neurotransmitter or the hormones act on the receptor and need to the G protein change, and then we can see here that the alpha is released, alpha is isolated by the beta gamma, and also that is this G protein is activity form, and also that he can also need to that the AC activity. Yeah. So that the G protein you have studied that you have studied the biochemistry course, and in here I hope you know that what is the second message. Second message is the Chinese name is 第二性质. Since we have studied that first message is the neurotransmitter and all the hormones. We call the first message. The second message we can I hope you know that what is the second message. It refers to the intracellular singular molecules generated after the first message act on the cell memory. It means that we can see here that he is generated by because the first message act on the memory receptor, and then need to generate it. So here that we call the first that. Second that these molecules can transport the information carried by the electrical signals molecule into the cells. It also means that he can because the information after cells change, and then he can transfer the information and into the cells. He can lead to the cells. This is also the actual singular molecules into the cells. He then need to the cells, the intracellular biological functions change. This change is also that the information based the change is be affected by the actual signals information. Yeah. So I hope you know that the second message. Do you understand? Yeah. Yeah. And the second message, I hope you know that the function that regulate target proteins. Regulate target proteins, and also that the protein catalysts and ion channels, and also and also change the signal function based on the conformational changes of the target proteins. So here that we just talk about that the CMP is also the second messenger, and also in the cells also have not only the CMP but also the calcium. Calcium is also one kind of the second messengers. Yeah. Do you understand? Calcium also have the one kind of the second messengers. Yeah. We have studied that the chapter 2 section 4, the skeletal muscle contraction. We have studied that the calcium in the cell is also one kind of second messages, because we can see here that he can transfer the information carried by the external signal fluid and into the cell. Yeah, have a yes, okay.
OK，老师。
Have a yes. Come back, good boys. Yeah. We'll continue. Okay. Here that we have know that the second messenger, and also then according to the second messenger is different. Also, we can see here that the if that we just talk about that the CMP is you use the CMP as the second messenger, like that the ADH and the CH and the TSH also that the catecholamines also that they are use the CMP, the second messenger. We can see that the first messenger, the hormones neurotransmitter, he binding to the G-protein coupled receptors. They are also need to the activate the G-proteins, and then also need to the AC activity, and also need to AMP become the CMP, and the CMP the second messenger, the second messenger. We can see here that like these G-proteins, yeah, and also there are the second messenger IP3 and the D and the calcium as the second messenger. Like that also, like that TH and the ADH also. Then these messages we can see here that first messenger, and then he also we have know that there are G-protein is either three chains, subject chains, also sub unit alpha, beta, gamma, and the alpha separate from the beta and the gamma sub unit, and also then he activated that the PLC, the phospholipase, lipase, we call the PLC. He activated PLC, and the PLC can activate the PIP2 and become to IP3 and DG. And also then this also that this also their second messenger, and IP3, and also they need to the ER you list you list the calcium. ER you list calcium also class C, and also then this also the PKC protein kinase C. The PKC can act cellular enzymes activity, and also they need to the intercellular biological effects. There we can see here that they are mainly that this second messenger IP3 and DG, and also the calcium. So this is not the same CMP and IP3, DG, and the calcium is the second messenger kind. You should know that. Okay. Yeah. Okay, I send. Yes, here.
Yes, 老师。
Now that yeah, and also that we can see that need to the ER release the ER release, also that the ER release the calcium, also that need to cells response. There also that we can see here that there G-proteins need to the IP3 and the DG and release also that, and also we can see DG also the need to the PKC activity, and also they need to the many cells the PKC cells all proteins activity, and then need to a cells response. They are we call that the calcium. This the second messenger is there to the calcium or IP3 and the DG. Yeah. And there is and also that is there and also some natural hormones mediated by the enzyme coupled receptor, not G-protein coupled receptor. This enzyme coupled receptor, like that the receptor itself has the enzymic activity, also known as the receptor, like that the tyrosine class. Tyrosine class, we can see that the insulin-like growth factor, insulin-like growth factor, he bound into the receptors, the receptor that tyrosine kinase, and also that we can see he bound in the actual memory and terminals, and then neutralize and binding the first messenger. And then the memory C terminus there with the tyrosine kinase activity, and they need to that intracellular biological effectors. Then we can see that there is now that we can see the singular conduction has nothing to do with the G pattern. That is them, is not a G pattern. And this is them, is that tyrosine kinase. And also that this now second messenger, we can see here that this receptor is bounding to the tyrosine kinase, and there is now second messenger. And also that there are no activation of the potent kinase in the cytoplasm. This tyrosine kinase is in the cell membrane, is not in the cytoplasm. Yeah, this that like that insulin like the growth factor. There is also that made up by the coupled receptor. This mediated pathway, you know that, okay. Yeah. And we talked about that the second messenger theory. There are, I hope you know that what is the second message? What is the second messenger? And also the kind of the second messenger include CMP and IP3 and DC and also calcium. And there is also that we have talked about that the neurotransmitter or the hormones act on the memory receptor. But some of them hormones can directly or simply feed into the cell membrane, and into the cell plasma, and then act on the receptor in the cells. The intracellular receptors. We call that like that intracellular receptor post-action. Intracellular post-action, like that with this mechanism, we call that gene expression theory. Next, that the hormones that the steroid hormone or the steroid hormone. These hormones is small molecules, is the lipid soluted small molecules. He can simple diffusion into the cell membrane and into the cell, across the cell membrane and into the cell. Yeah, you understand? Yeah. And now we force that the mechanism these hormones enter the cell membrane is directly there. We have talked about that only this kind of that the steroid, according to the structure of the molecules or the hormones, these hormones can directly enter the cell membrane, and the cell membrane and also the into the cell, and then he bound into the plasma cytoplasmal receptor. He bound into the cytoplasmal receptor, and then also that these hormones bound into the receptor, and then made up generate the HR complex. HR complex is H is all hormone, R receptor. Then this HR complex and then enter into the nucleus, enter nucleus, and then there are also that this is the also this receptor is in the cytoplasm, and also there this HR complex and then enter the nucleus and then into the internucleus, and there we can see that HR concept also can bound into the cellular receptors. We can see here that also that we can also that he can also he can bounding the nuclear receptor. Then we can see here that this is also that the HR complex. Yeah, and also that this receptor that this complex bounding to them potent specific site in the committee, and also then need to that he can regulate the DNA transcription. DNA transcription, we can see here that he need to also the DNA transcription and also they need to the intracellular biological effect. This also that he can regulate the DNA transcription, and also even regulate the we can see here that he also that he regulate the potency expressing or potency derivation, and also that he regulates the levels of potency. So here that the need to the intracellular biological effect. Then we can see here that this also then he influence the gene expression. So then we call that this intracellular receptor post action is that gene expression theory. Yeah. Understand? Yeah. I hope you know that this kind that the kind of hormone is that like that the steroid and also that thyroid hormones. These thyroid hormones. This kind of the hormones can by this the gene expression theory or regulate the gene expression, and also they are also that the then he act on the nucleus into the nucleus, and then act on the DNA transcription. Yeah. Then we talk about that the hormones action include that the hormones the hormone post action include that the second messenger theory and also the gene expression theory. Understand?
Yes, Monsieur.
Okay. Here that I hope you know that. Okay, and then we know that the different hormones also have the act on the different functions on the target cells, and then influence or regulate the target cells functions. And then according to all the hormones, then we have, I hope you understand and master the general factors of the hormone action. The general factors of the hormone vaccine include four actions. First, that specific effect. Specific effect, then also that is also that he means that specificity. Specificity means that the hormones act selectively only on the target cells that recognize it. It means that only these cells have the receptor. This receptor can recognize the hormones. Then we have know that if the cells have no the receptor, this receptor cannot recognize the hormones. There is also that we not call this target cell. Only these cells have the receptor. This receptor can recognize the hormones and then can binding the hormones. Then we call that this is the target cells. So that we can see that this is specificity, and also that the hormone, also that the specific effect, and then and also that there is also that this specific is based on depend on the binding ability. The binding ability is also that the target cells is specific receptor to the hormones. We call this is that the affinity. Affinity means that the binding ability of the specific receptor to the hormones. And then if the affinity is higher, and then the binding ability is higher, and they need to, and also they need hormone action normal hormone actions can produce them. But if the affinity decrease, and also then maybe because the receptor expression level decrease, also then maybe the receptor dysfunction, and also they need to the hormones action cannot be take part in or regulate the target cells functions. Yeah. So then we can see here that the hormone action first that based on the affinity like that. We have known that the insulin is resistant. Insulin is resistant. Also, there may be because that the insulin receptor cannot the affinity between the ability of the insulin receptor and the insulins decrease, and also then in the blood have a normal concentration of the insulin, but that they cannot the insulin's actions. Yeah, so that I hope you know that the ability. Do you understand the ability? Yeah. Do you understand?
Yes.
Yeah. According to the ability, I also know that if the hormones, the first we have know that the hormones can be secret or released by the target the endocrine cells. If the endocrine cells function decrease, and also they need to the hormones levels decrease. The hormone levels decrease, and then we have now the hormones act on the binding to receptors, and these receptors is also potence. Their potence. The potence number or the binding point, binding site on the potence is also limited. But that if the hormone levels decrease first stage, first period, if the hormone concentration decrease, and also that receptor, we have know the receptor also can the number of receptors or the binding site of receptors can up down after regulation. And also then the receptors is pressure increase, but that but at the same time, if the human concentration is higher on their level, and also the receptor also down regulation, and this rule like that to the neurotransmitter and binding to the receptors. Yeah. So this is a specific effect. I hope you understand that. And the second, that the messenger rule. The messenger rule, we talked about that the human is the first messenger, the first messenger. He can bind into the cell memory, and also then he can activate and also activate, and then need to the activate the second messenger produced, and then regulate the biological reactions. So here that the human is the messenger rule, is the first messenger. Messenger, we should know that we know that there are, he can transmit the letter to from one people or from one point and to another people another point, and then he cannot change the letter. He can change letter. So the messenger, we have know that it means that it means that he transmit the information. And also that he created the psychological, physiological, and biochemical reactions of the target cells, but doesn't add new functions. Only the transmission, only the transmission, and also doesn't provide the additional energy, and doesn't provide the additional message energy. Though, so that we call the message rule. Yeah. Only that his function is that transmit information. Understand here? Yeah. Do you understand here?
Yes.
Yeah. So that I hope you know the hormone action is the messenger rule, and also that is the first messenger. Yeah. And the third, and that efficiency effect. Efficiency effect means that also that he is a lower concentration, but also have the strong effect. It also we have noted the hormone in our blood or in our body is the lower contraction, and also that but that give a strong effect. We call that this efficient effect. Chinese name is 高效. It means that we have now that the hormone binding the receptor, and then need to the intercellular singular conduction step by step application of amplification. Application, and also then determining the efficiency by magnification effect. So here that is the efficient by magnification effect. Then we call the efficient effect. the third hormone actions. Yeah. The next that we can see here that this is the this next that we can see here that this hormones that he can by this serious enzymes activity, and also they need to that by we call this the cell biochemistry reactions. That also the by magnificate protein of the hormones. There we can see here that this there we can see that this no constriction, but that we can see here that is a higher efficiency effect. Yeah, another fourth action we call that interaction, and also 产生相互作用。And we have know that in our body also have a lot of the hormones, and also then hormones and then can be affected by a lot of hormones. And then a lot of hormones, and then we can see here that this also that the interactions include that the synergistic action, like that we can see that in the blood glucose concentration can be regulated by the growth hormone, and also can be regulated by the glucocorticoid hormone. And the glucocorticoid hormone, and also then he can increase the blood glucose, and also the growth hormone also can lead to the blood glucose concentration increase. Then this same actions we call that the synergistic action. Yeah, understand here?
Yes, Launcher.
Yeah, and also there we can see here that there the anti-galactic actions 强烈的拮抗作用。We can see here that also the blood signal, the blood glucose or blood glucose concentration. We can see that glucagon can increase the blood glucose, but the insulin is decrease the blood glucose. Then we can see the actions is opposite. Then we call that anti-galactic action. And there is also the different or the opposite actions. And the third that is the permissive action, 允许作用 permissive action. What is the permissive action? This the cyclic action and the anti-galactic action is easy to understand. Yeah. These two actions is easy to understand. Yeah. Yes or no?
Yes, Launcher.
Yeah. And here that the permissive action, there I hope you know that what is permissive action. This concept I hope you master and remember. And there in some cases, and then there the permissive the percent of one hormone is needed for a larger hormone to exist its actions. It means that this hormone has these actions, but that his actions can be produced and should need one hormone. And then if this hormone exists, and then this other hormones these hormones actions cannot produce. So but that this one hormone cannot its actions, but only he support and needed for the other hormones. We call that permissive action. Like that, this we can see that we can know that the catechol domains include that the dopamine, and also include the NE, and also NE is also this is also the three kind of the catecholamines. Catecholamines means he can regulate the cardiovascular activity. We have know that, but that this functions also that he should need to the glucose. He should need to the glucocorticoid. And then if the glucocorticoid exists, and there is the NE and E and also dopamine can regulate the cardiovascular activity. And then we call also that this is the according to the catecholamine, and then this is the should need to the glucocorticoid. We call that the permissive action. Yeah. So here that understand. Understand?
Yes, 老师。
If in the body, we have known that the glucocorticoid in our body is very important, the hormones. But if this this concentration of this glucocorticoid decrease and no this there, and also then if there in the body no glucocorticoid, their body is die. And then if this no that, and then we have known that the catecholamines action is also decrease, and even know the actions. So here that the according to the catecholamines, he based on he needed the glucocorticoid, and also then we call that the corticoid is the permissive action to the catecholamines. Yeah, I hope you know that, understand that. Then the permissive actions there we have, I hope you know that. So here that the general factors of the hormone actions include that sufficient effect, message role, and also the efficient effect, and also the interactions. Interactions in here that they are permissive actions. Yeah, we can see here that there is a cyclic effects of hormones. We can see only the cortisol and only the epinephrine, and also only the glucagon. And we can see here this have increase the blood glucose. But that this is three. We can see here this two hormones exist, and then he can higher euglycine, high euglycine. And also these three, and also we can see here his higher euglycine. And then we can see this is because this is the same actions there on the blood glucose. We call that the synergistic effect. Yeah. And also the hormone secretion rhythm and the regulation of the secretion. And there is also we have tested the blood, the hormones concentration. We found that the hormones regulation can be changed by the times, different times in one day. 24 hours. We found that like that we can find that in the light also that. Also that we can find that in light the growth hormone about after the 12 or the morning one morning, and then we can see that there is the growth hormone is a higher concentration, and also found that the endocrine hormones there is a lower concentration. And there is majorly the higher than the morning 8 o'clock. And also melatonin also found that the morning about 4 o'clock. We can see here that is before the night, like that the morning between the 4 and 5 o'clock. There's a higher concentration. So here found that their hormone secretion is also rhythm. Also we can see there are also the rhythm. Also we call that biological clock. The biorhythm secretion we call the biological clock. And their biological clock there can be visually that in the brain that the hypothalamus chiasmatic nucleus. Then there may be this period is maybe a key point of the body's biological clock. I hope you know that there. And also then there are about 20 years there, according to the biological clock, can be paid. There majorly the three scientists win the Nobel Prize. Yeah. Here that I know that they are according to this the rule of the hormone secretion rhythm. So that we know that like that we can see here that if you take the drugs or like that the endocrine hormones, then because in the body also have a higher concentration, and also then in the morning take these drugs, and then lead to the hormones concentration is a higher level, and then have a perfect and a higher function. Yeah. Can you understand?
Yes, 老师。
Yeah, and also I hope you know that the hormones secretion or release in secretion in the body also follow the biological clock, and also there are this that especially we can see here that the baby is also in the growth and development, and then if that because there's growth hormone. We have not in the evening like that after 12 or this growth hormone secretion, and there is and also there if the biological if the baby in the evening doesn't sleep, and also then this is releasing this is the secretion decrease, and also then affect the body's the development of growth, and also so here that. Follow this is the rule, and also then should make the baby sleep earlier in the evening, and also then during the sleeping, and also we have talked about that the sleeping also that especially the snow wave sleeping, and then into the growth hormone release the secret higher secretion, and then promote the body's development. Yeah. Here that also that regulation of the hormone secretion. The hormone secretion can be regulated that many regulation like the body fluid regulation. Body fluid regulation there is also we can see here that the shift feedback adjustment, and there we can see here that this the hypothalamus, and also hypothalamus and anterior peptides, and also that endocrine context, and also target cells of the cortex cells. This also we call the HPA axons. We call the hypothalamic pituitary target cell. We call that the target cell. We call this the HPA axis. HPA axis. We can see here this the hypothalamus can they are released secrete the CRH hormones. CRH hormones, and then he can regulate the regulate the anterior peptide release the ACH secrete the ACH, and also then can regulate the endocrine context and the cortisol secrete, and then he can the cortisol secrete in the blood, and then target cells or then need to the response to the increase the cortical cells. And we can see here that at the same time that if the cortisol concentration in the plasma cortisol concentration in a high degree, he can also that inhibit the anterior pituitary, and also the hypothalamus secrete the CRH, and also that inhibit the pituitary secrete the ATH. They all we call that negative feedback. And here we can see here that he there is also this the long far we can see this the long feedback, this the short feedback, and also that the ultra short feedback, and also at the same time maybe he can lead to the endocrine context release the cortisol. There we can see here that the HPA axons there is long feedback and short feedback and ultra short feedback. This feedback is negative feedback. Do you know the negative feedback? Yeah. We have studied that negative feedback, the capital one feedback. We have studied the negative feedback and the positive feedback. Do you remember? Yeah. Who remember?
Yes.
Negative feedback, you remember? We have studied that negative feedback is very important. He keep the homeostasis, maintain the homeostasis of the body. We can see here that their cortisol concentration is higher. He can inhibit this secrete the hormones and then keep the balance of the hormones concentration. And there we have know that the negative feedback is very important to maintain the homeostasis of the body. Yeah, answer here.
Yes. Yes, Lasha.
Yeah. And there is, I have know that the body fluid regulation, also they regulate the hormones secretion. And also some metabolic regulation effect, and also some the neuromodulation. Yeah. And there we can see here that like that the hypothalamus he released the TRH. TRH also that he can and then secrete that also then he regulated the anterior peptide and then you release the TSH. TSH we can see here that he also regulated the thyroid gland, and then also that he released the T3 and the T4. And then if the T3 and T4 in the blood is higher, and also he can also regulate the TRH release, increase the TRH release and then increase the TSH increase. And also this is negative, and also they need to the T3 and the T4 concentration in the keep a balance. And they are this regulation we call the feedback. Feedback we can see the feedback. Then also they need to the in the blood into the hormones concentration in the balance, hormones concentration balance. Yeah, and also that this then we can see here that this TRH, TSH, and T3 and T4. And also like that this also that the CRH is also the same. And then we can see here that this is also that the neural and the hormone regulator pathway of the hormone secretion. And also that is also this is also we can see this is the longer feedback, and also that this the short feedback is ultra short feedback. This is a short feedback. Yeah, we can see these are negative feedback. Yeah. In the chapter 1, section 1, I hope you understand this majorly the concept, the permissive actions. I hope you understand what is the permissive actions and the endocrine and the hormone. And there is majorly I hope you understand that the general factor of the hormone action, and also that the way of the hormone deliver information. Yeah. And there are section 2. Section 2, we will study that the different endocrine gland and endocrine system. Endocrine system, we have know that in the brains there is also very important that the hypothalamus. The hypothalamus also in the hypothalamus of a lot of the neurons. The neurons also have the functions. Also the endocrine cells. He can secrete the hormones. So that these hormones can be hypothalamus secrete the hormones and also they transmit to the pituitary gland. The pituitary gland we can see here that is also that there is also that there is the anterior peptide. This is also that the posterior pituitary, and also there is then this the hormones can regulate the functions of the anterior peptide and regulate the posterior peptide. So here there we call that the hypothalamic peptide and also the pineal endocrine. And I have know that this is and then between the hypothalamus and the peptides is two pathway. And also this is that the hypothalamus and the anterior peptide, and also hypothalamus and the posterior peptide. Yeah. Understand?
Yes, Marcia.
Yeah, and in the section 2, I hope you understand and master the majorly that the growth hormone. The growth hormone very important, and another hormone you know about a female with that okay, and the growth hormone I hope you know that, and also that the female with the concept and the English derivation of the HIP. I hope you know that HIP that you means that, and also the also that the peptide gland, and I hope you know that. Yeah, we talked about that between the similar hypothalamus and the peptides in the two pathway, and here that there we call that the functional connection between the hypothalamus and the peptides. This we also call that hypothalamus peptide system endocrine into the peptides into pathway. One, the hypothalamus and the post we can see hypothalamus the post peptides they are majorly that the hypothalamic peptide tract. And the second that the hypothalamus is the anterior peptides, this peptide gland. There is means that this peptide gland also have the endocrine functions. He can also endocrine and secrete the hormones. This is two pathway we can see here that yeah. Answer here.
Yes, Marcia.
Yeah. The first that we will start that the hypothalamus and the hypothalamus and the anterior peptide. Yeah, in that there we also the peptide regions there means that the perivascular neurons of the medulla base of the hypothalamus, this is the hypothalamus, and also make up the peptibular neural secretory system. This we have know that it means that in this hypothalamus, these regions also these neurons can release the secret the hormones there, and also there are these hormones that in this peptide regions in the hypothalamus there. This we call that perivascular neurons. These neurons can release the molecules we call that hypothalamic regulatory peptide. We call that HIP. What is the HIP? I hope you know that the peptide substance secreted by the small cell neurons. These small cell neurons in the hypothalamic promoting peptide regions. And then this that which can regulate the activity of the pituitary gland, and their HIP can be transported to the peptide gland, and then can regulate the peptide gland functions. So that we call that HIP. But that HIP be secreted by the small cell membrane cell neurons of the hypothalamus. This hypothalamus is that we call that promoting peptide regions, and so that we know that HIP is secreted by the hypothalamus neurons. That's that here. Do you understand here? Yeah. I hope you understand here. Yeah, this class we will talk about here. And there are this is majorly that the chemical peptide and the main effect of the hypothalamus, like that TRH, and also in the hypothalamus, he can promote the TSH and the PRL secretion in the peptide gland. And also GRH also then he propel to the AH and the FH released in the secret in the peptide gland, and also this CRH also he can lead to ACTH release the secret in the peptide gland, and like that. Yeah, this class we talk about here. Goodbye.
好的，老师，谢谢
谢
老师，
老师，
再见，
谢谢，
再见，
再见，
谢谢
拜
老师，
拜。
再见，
拜拜。